Okay, let's talk about now the different ways that we could prepare an amide. So amides generally cannot be made from carboxylic acids without some specialized reagents. So for example, if we take this carboxylic acid here and we try to treat this with dimethylamine, and we try to heat these two up in reflux, or we add acid, the reaction does not proceed as drawn to give us this dimethyl amide and a molecule of water. Now, the reason for that is several-fold, but basically the carboxylic acids are acidic, as we've learned, and dimethylamine is basic. One of the primary characteristics of amines is that they are moderate bases. So what actually happens is the carboxylic acid is deprotonated to give you the carboxylate, and that's resonance stabilized, and then we form the protonated amine. And so there's two things wrong with this picture. We want this carboxylic acid to be the electrophile, but it can't be the electrophile. Nothing is going to attack a positive charge, right? It's not positive. A negatively charged thing or a neutral thing isn't going to attack this negatively charged molecule. And this can't be the nucleophile because there's no lone pairs. Okay, there's no lone pairs on the nitrogen. So it's just wrong on so many fronts. So the acid-base reaction kills this reaction, and that's why this reaction does not occur as written. In order to make this dimethyl amide, as we have shown here, we would need to first take the carboxylic acid, convert that with thionyl chloride to the acid chloride, and then treat this with two equivalents of dimethylamine to give us this molecule here. And let's name this for practice. This is NN-dimethyl 1, 2, 3, 4 butanamide. How does this mechanism work, and why do you need two equivalents? So let's take a look at the acid chloride. The acid chloride, as we've learned, has a good leaving group, and our nitrogen from the amine is a sufficiently strong nucleophile to directly attack acid chlorides. We get the infamous tetrahedral intermediate, and we get this Witter ionic structure here. Now, I'm going to go ahead and kick off the chloride. Chloride is a sufficiently good leaving group to do so at this stage. And we get this molecule here, and chloride floating around. Now, this is not the amide. It has an extra proton, and this is where the second equivalent of amine comes in place. So our amine, remember again, is a good nucleophile or a good base, and so for here at the last step, we want to use this as a base to deprotonate that proton and giving us the neutral target molecule, NN-dimethyl butanamide, okay? So that's the generalized process. You can do this with any primary or secondary amines. So for example, if we wanted to make this molecule here, what would that come from? We would want to split this molecule down, the acyl bond, and we would get, remember again, we don't want to write the carboxylic acid, we want to write the acid chloride as a suitable starting material. And then remember again, we would need two equivalents, and we would need 1, 2, 3, 4 carbons attached to a nitrogen. So that's one way of drawing it, okay? This works for cyclic amides as well, or aromatic amides. So these are both secondary amides. And this is a cyclic tertiary amide. Okay. So for your homework question, try to propose what carboxylic acid chlorides so what acid chloride and amine could make these. Okay. So that's a little bit of basics into how to prepare the amides, okay?